Alright, so here I just want to use one example to show you how to solve a problem on the time value of money where the interest rate is compounded not annually. For example, monthly, quarterly, or sometimes, like in this case, even daily. For those problems, the technique is actually very similar to the technique which we use to solve the annually compounded interest rate case. We just need to work with the number of periods rather than the number of years, and the periodic interest rate rather than the annual interest rate. For example, if we have the quarterly compounding, then we just need to get the number of quarters rather than the number of years, and the quarterly interest rate rather than the annual interest rate. But keep in mind, as a convention, the interest rate is by default is always quoted annually. So we call that the annual percentage rate, or APR. So if the interest rate is not compounded annually, but as I said, in general it's quoted annually, so we need to get the periodic interest rate. So how can we get a periodic interest rate? For example, if it's quarterly compounding, but as I said, the interest rate is still quoted annually. So we just need to divide that APR, annual percentage rate, by the number of quarters within a year, which is obviously 4. So we just divide APR by 4 to get the quarterly interest rate. And then we just need to get the number of quarters. That's very straightforward. Just multiply the number of years by the 4 to get the number of quarters. So that's the technique we can use to solve the time value of money questions for non-annually compounded interest rate. So here the example I want to discuss is actually one of the homework question, which is number 9 in your homework 2. So the setup says an investment will pay you $47,000 in 11 years if the appropriate discount rate is 7.4%, compounded daily. What is the present value? So as we said, if we are calculating present value, we call, in that case, the interest rate is also called the discount rate. And the reason is that because to get present value, we need to discount the future value back to present. And in general, the present value is smaller than the future value. And so that's why in that case, the interest rate is also called the discount rate. And here the 7.4%, as I said, without any further information. For example, if the question specifically tells you that the daily interest rate is 7.4%, then obviously you don't have to do anything about interest rate because you already know the daily interest rate. But here, the question says 7.4% and compounded daily. So that means 7.4% here is the annual percentage rate rather than the daily interest rate. So in other words, this is the annual rate. So to get the daily rate, we need to divide this number by the number of days within a year. So according to the instruction, we should assume 365 days for a year. So we need to divide 7.4% by 365 to get the daily interest rate. And you also have to read this instruction carefully. It also tells you do not round intermediate calculations and round your final answer to 2 decimal places. And very importantly, do not round intermediate calculations. That's actually quite important in our question here because we need to get the daily interest rate. As we said, we need to divide 7.4% by 365 to get the daily interest rate. But do not get that number in your calculator for the intermediate step. You can just directly input the whole thing into the calculator later. Alright, so let me use the OneNote just to solve this question so you can see better what I mean. Okay, so first I want to write down the formula for the present value of a future value, right? So here if we go back to the setup, we only have one cash flow. So the question asking what's the present value of that cash flow. So obviously we can use the formula of a present value equals future value at time t times 1 plus interest rate and raised to the power of negative t. Okay, so the power for the present value calculation is negative, and for the future value calculation is positive. And that's very important. Okay, so just to now it's very important. The trick to solve any time value of money question, actually the biggest hurdle is to get to use the right framework to analyze the question. So here it's very simple. There's only one cash flow, and that's in the future, and they're asking for the present value. So obviously we need to use this formula. But then the next step is to get the numbers for all these inputs here. So first we get a number for the future value, and that's given by 47,000. And next is the interest rate. As we said, here we are working with the daily compounding case, so we need to get the daily interest rate. But what's given is what we call the APR, which stands for annual percentage rate. Actually, if you apply the credit card, the interest rate given by the for the credit card is the APR. So you probably are not so unfamiliar with this term APR. So APR here is 7.4%, and that's an annual rate. And so, but here we need to get the daily interest rate. So we need to divide this 7.4% by the number of days within a year, so that's going to be 365. So if you go back to the instruction, it says do not round intermediate calculations. So the reason is the interest rate here actually is going to have a very dramatic effect on the final result, especially when the number of periods is large, and that turns out to be the case for this question. So now let's get t. So again, we have to be very importantly, we have to be consistent. We are working with the daily interest rate, so we also need to work with the number of days rather than the number of years. So the number of years is 11, hence it's very straightforward to get the number of days. So it's 11 times 1 as 365, and that gives us, if I find a calculator, 11, yes, 11 times 365, and that gives me 4015. Go back. So here it's gonna be 4015. Okay, so now we have every input to plug in this formula to get this present value. So present value now equals 47,000 times 1 plus, again, just put this whole chunk in, 7.4% divided by 365 and raised to the power of negative 4015. Okay, so now let's use the calculator to figure out the final answer. So just put everything into the calculator. Okay, so 47,000 times parentheses, left parentheses, 1 plus 7.4. I don't have a percentage sign, so I need to divide this by 100. And then divide by the number of days within a year, 365. And then write parentheses and reach the power. I need a power function. And in this specific calculator, it doesn't have a y to the x or x to the y. It only has this similar sign. I don't know how to call it. It's a sort of a triangle, but it's not an exact triangle. So, but that's the same as the power function, and raised to the power of negative. Okay, so we need negative sign. So I also need left parentheses, negative 4015. Okay, enter. So the final answer is 26.58. Okay, so just write down number here. So it's 28. Go back. Oh, sorry, it's not 28. It's actually it's actually 20. So it's 20, and then 8, 26 point point, not dot. Okay, so that's point. Um, 58. So now let me get this number into our connect site to check whether we have got the right number. So it's 28, 26.58. Okay, so let me check my work and say whether we have got the right answer. It tells me you already used the maximum number of check my work attempts permitted, because I already checked once. So here I just I guess I just need to submit my work to see whether I got the right number. Okay, so why this is not popping up? Yeah, sometimes the connection here is very slow, so excuse me for that. So what can I do now? Oh, I don't need to access ebook. So save and exit, submit assignments. Okay, so let me just submit assignments. Yeah, here because I haven't completed the other question in this homework, so obviously other ones will not be correct. But I'm only interested in knowing this answer to this question, and it turns out we got the right answer. Okay, so here I'm just using this example to show you how to solve questions on the time value of money, where the interest rate is not compounded annually. Again, the technique actually is very similar to what we used in solving the questions where the interest rate is compounded annually. The only difference is that we need to work with the number of periods rather than the number of years, depending on the compounding periods. And also we need to work with the periodic interest rate rather than the annual interest rate. Okay, that's it for this discussion.